Okay, we're going to review the burning candle problem from Module 2, Investigation 4. This is problem number 5. And in the first sentence we see that the length of a burning candle decreases at a constant rate of 2.2 inches per hour. So the length of the candle varies with the number of hours that have elapsed since the candle was lit. And important for us, we see that this rate of change is constant. For any time elapse of an hour, the candle's length will decrease by 2.2 inches. We're given another piece of information. We might call this a data point. When the candle has been burning for 3.5 hours, it is exactly 8.3 inches long. And later down the page, you might see that here in red, we could graph the the ordered pair, 3.5 hours, comma, 8.3 inches. And so from the origin on this graph, which you may not see well, we've moved 3.5 inches, actually that's hours, 3.5 hours to the right, and then we moved up 8.3 on the inches axis, and there's a label there. And I want to remind you what it means, or we'll remind ourselves what constant rate means. I'm going to grab a piece of paper here where I already have some variables defined. If we let script L represent the length of the candle in inches, and I think I want to add the word varying, the varying length of the candle in inches as it burns. And if we define N to be the changing number of hours since the candle was lit, then because length varies with respect to number of hours at a constant rate, we can write this relation. Change in L equals negative 2.2 times change in N. And recall, change in L is L2 minus L1, final length minus initial length, and change in N would be N sub 2 minus N sub 1, final number of hours minus initial number of hours. Okay. Now to review what the next question is, question A asks us to represent an increase in time spent burning of 2 hours from the given point on the graph. Okay, that doesn't have to be too difficult. Each hash mark along this horizontal axis represents 1 hour. And so I just need to move to the right the equivalent of 2 hash marks. So if I start at 3.5 hours, I will add 2 hours, draw a horizontal directed line segment, and time is increasing, so I put an arrowhead to the right. Then the follow-up question to A is, how much will the length of the candle in inches change when the time spent burning increases by 2 hours? Represent this on the graph. So we expect to draw a directed line segment downward where the tip of the arrow will end at our next data point. Okay, we have to do some calculations before we can draw the answer to B. So to think through part B, we have one relation from the given, that change in L is always negative 2.2 times the change in N. The length of the candle increases. I said that wrong. The change in the length of the candle will be negative 2.2 times the change in number of hours. Okay, so previously in part A, we represented an increase of 2 hours from the 3.5 hour mark. So if I record this in our little table here, I already knew at 3.5 hours the length of the candle was 8.3. So 2 hours later, we'll have change in N equals 2. 2 hours later, we'll be at the 5.5 hour mark. What will change in L be? How much will we decrease the 8.3? Okay, we simply need to find the unknown change in L. We take negative 2.2 times the change in number of hours, and we find that in 2 hours, change in L is negative 4.4. So we subtract 4.4 from the current height, which will give us 3.9. Okay, this might be a place you want to pause the video and think, how did we arrive at 3.9? Okay. And just as a follow-up, you might need to speed through this. Going back to our original data point, at 3.5 hours past the time the candle was lit, if the candle was 8.3 inches, then if we add 1 more hour, according to the given, we would subtract 2 inches. And then if we increase the number of hours 1 more time by an hour, we would subtract another 2.2, which would also get us down to 3.9 inches. Which brings us back to graphing. So on the graph, we want to represent a decrease in the candle height of 4.4 inches. The tip of the arrow will end up on 3.9. So the new data point is 5.5 hours, 3.9 inches. But the length of the green segment is negative 4.4. Change in N was the length of the red segment. Change in L is the directed length, inches, in the vertical segment. Okay. We're moving on to the next page, part C, D, E, and F of the candle problem number 5. Okay. The author wants us to represent a decrease in time. That'll take us back to the graph. Okay, keep in mind we want a segment of length 1.8, but we have decreasing time, so it's in the negative direction. Okay, let's see if I can get myself situated here. Yes, okay, let me use a different color here. If we decrease 1.8 hours, then we're going kind of backwards in time, and we'll have a corresponding increase in the length of the segment. I just need to figure out how long that little segment going upward is going to be. Okay. So now we're working on part C, where we wanted to have change in number of hours as a minus 1.8. So the corresponding change in L will be negative 2.2 times negative 1.8. Okay, so a quick calculation. Maybe you can double check me on this. I hadn't worked through this. Twice 18 would be 36. We have 2 decimal points, so almost an increase in 4 inches. Okay, change in L that corresponds to a change in N of negative 1.8 would be a positive 3.96 inches, where this was in hours. Okay, going back to the graph. So in aquamarine, I've moved left 1.8, I hope. Probably not enough. Nope. That was probably just 1 unit, and then I need almost 2. That's 1.8. And then my purple segment needs to go up almost 4. 1, 2, 3, 4. This might be a good time to pause as well and think about the answer to part C.